Hi, my name is Joel. Thanks for coming to this session. Today I'm going to share some lessons we've learned building ViewComponents at GitHub over the past year. I'm an engineer on the design systems team at GitHub, and we're responsible for the primer design system used throughout GitHub. As you can see, it's really a system of systems covering areas like CSS, React, we have an icon library, and Figma styles, and kind of the things you'd expect in a typical design system these days. My job on the team is to make building consistent, accessible, and resilient UI in our Rails monolith an enjoyable experience, all at a pretty incredible scale. To give you an idea of our scale, here are a few stats. It seems like people always ask me about these when I'm talking about our application. The GitHub Rails app is over 13 years old, and it receives tens of thousands of requests per second. We've extracted around 24 services at this point into what some people call a Citadel architecture. A lot of our services are written in Go and include functional areas such as webhook delivery. But most of GitHub is a Rails monolith, and it's a big monolith that's growing quickly. We have over almost 600 models that we've added about 33% of those in the past year. We have almost 4,700 views, of which we've added about 20% over the past year. And over 800 controllers, almost 37% of what we've added in the past year. We have over 2,000 pages in the application, and all of them need to stay current, even if they're obscure settings pages out of the critical path that you might never even know exist. This scale makes for some interesting problems. Things that might be a small annoyance in smaller applications can become serious roadblocks at our scale. When you have a body of work at the scale of our application, patterns start to emerge. One issue we've had is figuring out which template rendered a specific line of HTML. So for example, when looking at a PR page, if I want to edit the badge that displays the draft status here under the PR title, how do I find the right place to make my change? I could try searching by the specific class names on the element, but this approach is often not very reliable if you're using functional CSS class names as we are here. In this case, if we search for some of the class names on this element, we get dozens, if not hundreds of results. In thinking about this problem, we came up with the idea to add HTML comments at the beginning and end of each template's output with the path to the template file, so we could see which template rendered which part of a page. So we did this by writing a custom ERB compiler. We start by defining our custom compiler as a subclass of the existing ERB compiler. That class has a method called call that receives a template object. To start our method, we get the original output of the ERB compiler by calling super, and then we take that output and we wrap it in HTML comments with the template's path. Finally, we take that compiler and we register it with Rails. Going back to our page, we can now see which template rendered a part of a page. In this case, it's actually our pull requests state component, ViewComponent. After seeing the benefits of this patch internally, we extracted it into Rails. It's now part of Rails 6.1. You can turn it on today with a configuration variable. It's config action view annotate template file names. And if you're building new Rails applications, this will be turned on by default in local development. Another issue that's come up is getting our application into the right state in local development so we can test visual changes. Part of this is due to GitHub's applications architecture. As I mentioned, we have a main Rails monolith and about 24 services. This can make it difficult to get our local development environment into the right state to test visual changes for our designers. Unfortunately, we don't have browser-based tests to do this, and this is mainly to do with how much time they would add to our CI suite. However, we do write plenty of controller tests. After numerous pairing sessions helping our designers get their development environment into just the right status so that they could preview the visual changes they were trying to make, I had an idea. What if we could temporarily convert controller tests into system tests? That way, we could reuse all of the existing setup code from our controller tests to preview the application in a specific state to make visual changes. So as a quick refresher, this is what a controller test looks like. It calls get with a URL and then makes an assertion, in this case, asserting against the response code. So how can we convert this into a system test? We can start by writing a module. We'll call it system test conversion. that when this model is included, registers some configuration for action dispatch system test case. Then in this case, we just need to redefine get to visit the path provided, and then pause with a debugger. And then for assert response, we'll basically just overwrite it as a no-op. From there, we can conditionally include this module if run in browser is appended to the command we use to run a test. So here's what it looks like in action. What we're running here is slightly more complex than what I just showed, but what it's doing here is it's now opening a browser, it's logging in, and previewing our page. Unlike template annotations, this hasn't made it into Rails. I'm not sure if it's as good of an idea, but it's served us well here at GitHub. But there's a more general lesson here. Our seeds and test setup code have a lot of overlap, and I'm curious to see if there's ways we could bridge the gap between these two conceptual domains. While working on these projects, we identified another source of friction. When modifying a template, it can be difficult to know where it's used. Not knowing where a template is used is risky, as we have a lot of template reuse that's nuanced across the application. My colleague John made a diagram of how our templates reference each other. As you can see, navigating our render stack is pretty tricky. So I built a tool called Viewfinder. Here's how it works. We pass in the template, in this case, the wiki show page. We then extract the template string literal, in this case, wiki/show, and search for it in the codebase. You can think of this just like you might search in your text editor. From there, for each search result, we load the file into the parser gem, which returns an abstract syntax tree of the file. For example, one of our search results is for a controller, and here's the part of that syntax tree. This data structure represents how Ruby interprets the code that we write. As an aside, the RubyComp linter actually works by analyzing these data structures. As you can see at the bottom, we have our render call to wiki/show. So for reference, here's the equivalent Ruby code for this tree. As you can see, this is kind of your typical respond to block from a controller with the format HTML calling render wiki/show. And then here's the equivalent syntax tree. Once we have the syntax tree, we can query it. I'm not going to go into a ton of detail at this point, but we are able to find the calls to render by looking at the type of the syntax node and then looking at the method name. And we do this to confirm that the render call is referring to the template we're trying to trace. We continue until we reach a controller action, and then going back to the syntax tree, we look up that syntax tree until we find the definition of the controller method, which in this case is the show method on the wiki controller. From there, we look up the routes that render that controller action. In this case, get wiki/path maps to wiki show. Then we return that result to the console. So as you can see here, we have two uses of our template that we found, where the route wiki user ID repository wiki path routes to the show method of the controller and renders that show template. We also actually reuse that template for the index section of the controller as well. So by itself, this tool was really useful. We could see all of the routes that rendered a template. But then we realized we could use these routes to identify which controller tests rendered our template. And we did this through a similar static analysis process to what got us to this point. So we start by finding all of the get calls from our controller tests by using this grep. So for example, here's a call that loads a wiki page. So we extract the argument from this call and pass it into the Rails code path that takes a request path and returns a route. In this case, it's Rails application routes recognize path. So we've taken that path from the test and called that method. And this returns this small hash that has the name of the controller, the action of the controller, and then the arguments that have been extracted from the path. We happen to only need the first two here. So we repeat this over and over for every controller test, and we build up a hash that looks something like this, where we have the controller action as the key, and the matching tests as an array of values. With this lookup hash, we can then include which tests render the view, and we can use these test cases with our system test conversion tool to visually verify changes to that template in a browser. There are a couple downsides though. This approach only works with explicit render calls, where a template name is passed to render. This is something we enforce with a linter, but it doesn't account for conditionals. This is an optimistic approach, so what we end up with is kind of all the possible routes that might render a template, not necessarily all like the ones you might want to use for a test. This has proved really useful for us, but it's definitely not ready for prime time. The biggest challenge we've been facing, though, at this scale of building views is a missing abstraction in our view layer. A common rule of abstraction is the rule of three. I really like Martin Fowler's definition from Refactoring, Ruby edition. The first time you do something, you just do it. The second time you do something similar, you wince at the duplication, but you do the duplicate thing anyway. The third time you do something similar, you refactor. Usually when we do something over again, we abstract it. If we don't, our code becomes inconsistent and hard to maintain. And this is especially true in our view code. We often build templates by copying existing ones, and this makes it incredibly difficult to make sweeping changes in our view code. And as someone on GitHub's design systems team, it really limits the leverage we have with our design system. More generally, our Rails code often doesn't live up to the standards we hold our Ruby code to. And views are generally tested with slow integration or system tests. Given all these problems, in 2019, I had this crazy idea that we could use Ruby objects to render views, inspired by ideas from React. We now call it ViewComponent, a framework for building reusable, testable, and encapsulated view components in Rails. A view component is a Ruby file and a template. So here's a simple one. On the left, we have our test component RB file. Test component is a subclass of ViewComponent base. It has an initializer that takes a title argument, and it assigns that argument to the title instance variable. In the component's template, we have a span with a title attribute that inserts that title instance variable, wrapping an accessor called content, which will be the content that's passed into the view component. To render it, we instantiate the component, pass in the title argument, and then pass a block that says hello world. All of this goes into the render method. As a result, we get this HTML. We have a span with the title of my title with the content hello world. To test this component, we can write a unit test that renders the component using the render inline method. You can see here we've instantiated it with the title and a block, kind of like we just did in our previous example. And then we can assert against the output using capybara matchers. In this case, we can look for a span with that specific title attribute with the text content hello world. These tests are really fast. In our code base, they're around 100 times faster than controller tests. Having this ability has really been a game changer for us. We used to treat tests that worked in the DOM as a luxury, and now they're basically free. So since then, we've rapidly adopted the pattern into github.com. To go back to our stats from earlier, the GitHub application grew by about 25% last year, except for our view components, which grew by over 15 times. And we've learned a lot in the process. One of the goals of the design systems team is to help our developers build consistent UI, and view components have been a key part of accomplishing this goal. So for example, last summer my colleague Christian built a view component for the counters we use throughout the app. Here you can see them on the repository navigation. We render these counters over 100 different places in the app. So looking at one of his pull requests rolling out this component, we can see that for one case, we wrap the amount for the counter in number with delimiter. And in another case on the same page, we didn't. This led to visual inconsistencies, but only in edge cases we'd really never expect a developer to think about when working on a feature. Now, instead, we simply pass the raw count value to the component, and it handles formatting the value in a consistent way. Another benefit we've seen from view components has been in helping developers write performant code. One of the most common performance issues I've seen in view code is unintentionally querying the database. For example, we often have permission checks in our views to determine whether to show certain elements or not. Unfortunately, these checks trigger database queries if they're not badged properly. So to help developers understand how their view code might interact with the database, we redefined that render inline helper that we use to render view components and unit tests to accept a number of allowed queries, defaulting to 0. So when we render the component, we fail the test if the actual number of queries doesn't match what was expected. And this helper has turned out to be quite educational. It's helped us understand the side effects of our code and prevented the introduction of several n+1 queries. In one recent case on the checks page, this saved over 100 milliseconds of overhead per request. Another advantage we've seen with ViewComponents is how they can help manage complexity. One example of this has been in our mailers. Building HTML emails can be tricky and often requires writing HTML like it's 1995. It's also really fraught with edge cases. Most of our mailers are written with that 1995 style inline HTML, and it's incredibly hard to maintain, let alone change without breaking something. So when we looked into adding columns to a mailer for this design you can see here, my colleague Mike thought we could build some view components to abstract away all of the tables in inline CSS necessary to pull this off. So to do this, he built mailer-specific components for rows and columns, which we use together. We wrap a row, which contains multiple columns. Together, this API gives developers a reliable way to build column layouts and mailers without having to worry about old-school HTML. This is a classic example of what Rails creator DHH calls conceptual compression. By simplifying the process for building mailers, we've practically removed the conceptual overhead necessary to build one correctly. Instead of worrying about whether you've written your inline styles in a way that renders properly in the numerous different email clients that exist, you can just piece together a couple of view components and move on with your life. Just like Active Record simplified our use of SQL and controllers made it easy to write code to respond to requests, we use view components to make building UI correctly the default, not the exception. Another way view components can help simplify building UI is with slots. Slots are a way to pass multiple blocks of content into a single component. So let's look at an example. This is the box component from the Primer design system. It has a header, a body, multiple rows, and a footer. And here's the HTML you use to build it. We have a header. It actually also has a specific class you put on a title if it's inside the header. We have a body. We have multiple rows expressed as an unordered list with li elements with a very specific class on it. And then we have a footer. So let's rewrite this as a view component. So let's start with a component that renders our example code. So to start, we have our app components box component. Pretty simple, just inherits from view component base. We have our template, which is literally the HTML we just had. And then when we go to render it, we render an instance of box component.new. Skipping a few steps ahead, you could imagine that we might end up with components for all of these pieces of a box. But this implementation puts a lot of burden on the developer using all of these components because for the box, the order of elements matters. The header needs to be first, the footer needs to be last, and just generally, this implementation here doesn't prevent the misuse of the design system. So this is where slots comes in. So we'll go back to our component, and using the slots API, we can declare one for the header, body, rows, and footer. In this case, explicitly saying that our box renders one footer, one header, one body, and potentially many rows. So in the template that renders the component, we can refactor it to use slots instead of separate components. So for example here, we render our box component.new, and then we pass in a header, we pass in a body, we actually pass in multiple rows, and then a footer. And then back in our components template, we can render that header, body, and in the case of the rows, they're actually exposed as an array, which means that we can do things, we can call enumerable methods on that slot and say, are there even any rows? If there are, we can output an unordered list. And then for each of those rows, we can output an li element with the correct class name, and then the content that was passed in for each row. And then the footer we render just like the header and the body. And we do all this inside that wrapping box div. So what we've ended up with here is a codification of our design system that helps developers use it properly. Another thing we've experimented with is Storybook. Storybook is an open source tool for developing components in isolation, and it's really popular. I think it has something like 60,000 stars on GitHub. And thanks to the work of community member John Palmer, it now supports ViewComponents. So here's an example of it in action with our Flash view component. Here you can see it previewing a change to the icon and a change to the variant. This gives us a development environment for building components outside of a Rails application, such as in our primary ViewComponents library. We open sourced this library over the summer, and it now has over 24 components. And we aren't the only ones doing so. The UK Department for Education has released a library of over a dozen ViewComponents for the GovUK design system. So one of the common questions I get about this project from folks outside of GitHub is, how are we rolling it out? It's sometimes asked in a technical context about writing new components, refactoring old views, etc. And sometimes in the organizational context. How do we ensure components are used appropriately? How do we make the case for this work with non-engineering stakeholders? That kind of thing. So let's start with the technical. How do we create view components? The first way is by refactoring existing view code into components. For example, before view components, we used a presenter-like pattern called view models, Ruby objects that we instantiate and then pass into views. So here's an example view model. It's kind of a plain old Ruby object, inherits from a view model base class. We have a status instance method that looks at the repository locked method and returns disabled or enabled. And here's what the test looks like. It instantiates the view and asserts against the object output. So that's a view model. We'd pass this object into a template and access some values from it, such as view.status. So here's what it looks like rewritten as a view component. As you can see, not much has changed. It's really just that we are now inheriting from ViewComponent base, and the name of our class happens to end in component. And for the test, not much really changes either. So we have a render inline method that takes an instance of our component, and then we're using a capybara matcher to assert that the text enabled is rendered. But there's something fundamentally different about this test. Instead of asserting against the attribute of an object, like we did with the view model, calling view.status, we're asserting against what's actually presented to the user. And this is something we previously could only do with system or integration tests. And it's one of the main reasons we refactor our view models to be view components. It gives us the confidence that our view code is working correctly from the perspective of our customers. We also write view components from scratch, and we consider the reasons I mentioned earlier. Is there a strong need for consistency? Are there performance concerns? Is the view complex with many different possible states? If so, we might use a component so we can unit test all the permutations. But the most common case for using view components is in place of a partial or a view model. When it comes to the organizational side of things, communication has been incredibly important, and it takes many different forms. One way we communicate about view components is via documentation. For our open-sourced primary view components, we use Yard, which is based on RDoc. And here's how we use it. At the top of a component's class, we write a comment describing the function of the component. We also provide examples written in an ERB of how to use the component, and then annotations for each of the parameters for the initializer. This allows us to keep our documentation alongside our code, making it more likely to stay up to date. But then the fun begins. We actually use these annotations to generate our documentation site. And here's how we do it. So in the library's rake file, we start by running the yard rake task, which parses the project for yard annotations. We then load the parsed yard annotations into the yard registry store object, which we can then use to retrieve the documentation for our specific component. At that point, we now have the parsed documentation available in a Ruby object, so let's inspect it. This object includes the class definition. It also has data on each method. Let's look at the one that is marked as the constructor. So first, we can see the names of all the parameters. We can also see the text of the example we wrote. Unfortunately, this example is still an ERB. We can fix that by instantiating our application controller and then passing this example into the render method as an inline template. From here, we have what we need to build our documentation page. We use that data to build a markdown file with the class name as the title, the description we wrote for the component below it, the inline HTML of the rendered example, and the original ERB code. Rendered on the docs site, it looks like this. This standardized approach keeps our documentation consistent. I think my favorite part of taking this approach is that our documentation is consumable both via the component's code's comments and via the published site, as people tend to prefer one or the other. Another way we communicate with other developers about ViewComponents is via linters. I've never seen linters used as extensively as they are at GitHub. For example, we have a bot that automatically reviews pull requests for cases where we'd prefer people to use existing ViewComponents. So you can see here we have a comment that says we'd prefer you use the primer Octocon component instead of this old Octocon helper. And it even includes a link to our documentation site that was generated by our yard comments. This saves us from having to make these suggestions manually in code reviews. Another way we use linters is with custom rubicops. We have a rubicop to encourage people to use ViewComponents instead of view models. It looks at class syntax tree nodes, and it sees if the class is a view model. And if it is, it adds an offense with a helpful message. At our scale, if we want to do something consistently, really the only answer for us is tooling and metrics that guide people towards the right solution automatically. Another way we communicate is weekly updates. For a lot of our projects, we use an issue to track our progress. Every week, we share a couple handfuls of highlights, such as improvements from using the pattern. In fact, like this presentation I'm giving now is actually a lot of examples from these weekly posts. This provides company leadership with case studies they can use to justify the work we're doing. At some point, though, there's no substitute for putting in the time. So over the summer, we put together a team of about a half dozen engineers and spent 2 months building new ViewComponents and rolling out existing ones. And the results were really dramatic. This is a graph of how many places we render a component in the github.com codebase. As you can see, this graph is pretty stable until August 1st, where the slope changes suddenly. In the 2 months the team worked on the rollout, which you can see reflected in the August and September statistics, we quadrupled the number of uses of components in the codebase. But even after the team disbanded, the gains continued. How could that be? I think part of it is that we now had a critical mass of component-based examples for engineers to reuse as they built new UI. But how do we ensure that they're using the correct examples? We did it with linters. So for example, if I was to use the non-component implementation of the counter pattern, I get this message. For each component, we set a number of places we allow for the non-component implementation to be used. If someone adds another usage, this linter fails their build and tells them to use the component. As we roll out a new component, we decrease the number of exceptions, preventing new exceptions from being introduced. We also reuse this code to generate a report on our progress. So for example, you can see here that we've migrated every single blank slate in github.com to use the ViewComponent that we built. One of the other questions I get about this project is what have we learned by open sourcing it? I should caveat this entire section by saying that this is the only open source project I've ever really worked on. But by many measures, the ViewComponent project has been very successful. We've been lucky to have a lot of engagement on the project. We've had code contributions from over 100 developers, only a dozen or so who work for GitHub. And working with so many different people from all around the world has been a huge lesson in empathy. What stuck out to me is that in every issue, PR, or discussion post, there is something to be learned, even the small stuff. If someone was confused by the documentation and wrote a component incorrectly, it's evidence that we can use to improve our docs. If an error message doesn't help someone fix the error and they file an issue about it, we should probably improve the error message. It's clear to me that people want to contribute, but they're not always sure how, which is why we focused on making it easy to contribute to the project. We want to enable people to make high-quality contributions as easily as possible. The library isn't super complicated, but it has some nuance and differing behavior across Rails versions, and we support the combinations of several versions of Ruby and Rails, making sure the framework works, which makes making sure the framework works across all of them a really critical part of working on the project. One way we've reduced the burden of this is through matrix builds. By running the test suite over a dozen combinations of Ruby and Rails, we're able to ensure every change works across all of these combinations. But perhaps more importantly, it's enabled us to ensure we have 100% test coverage by combining coverage data from all of these matrix builds. This gives us a confident foundation that makes it easier to accept contributions from the community. So we do this with artifacts. In our actions configuration, we upload the contents of the simplecov directory as an artifact for each test build. And then in a dependent build that runs after all of the test builds, we download all of the coverage artifacts and run a rake task to combine the coverage results. And it's really quite simple. The task loads the artifacts into the simplecov collator, which we configure with a 100% test coverage requirement. This means that a build will fail if it contains untested code. With all this infrastructure in place, it's a lot easier to accept PRs with passing tests, since we can be pretty sure that they won't break existing APIs. Another lesson I've learned working on this project is how powerful the Rails conventions are. When writing ViewComponent, we aim to conceptually align the framework with Rails as much as possible. And what we've seen is that Rails conventions mean baseline expectations even outside of Rails itself. And these conventions have enabled others to almost instinctively know how to contribute to the project. For example, Juan Manuel contributed ViewComponent previews largely based on the convention established by Action Mailer previews. I also think that it's worth talking about what hasn't been going so well in the project. There's one problem with this approach that I just can't shake. It means we now have two ways of writing views that work differently. I can't imagine Rails having native support for view components because of this, at least as they exist today in a separate directory. But it makes me wonder if we could extract some of the lessons from ViewComponent into Rails. One example of this is Andrew Culver and Dom Christie's Nice Partials gem. Nice Partials provides a similar API to the ViewComponent slots feature that I just talked about. It allows for multiple blocks of content to be passed into a partial. Maybe this is something we could add to Rails. I think this is what we ultimately need to focus on in the long term. From our work on ViewComponent, we've identified ways ActionView could be improved. And as ViewComponent's API matures, we'll have an increasingly clear idea of what those improvements might look like. By doing so, we'll be able to design the future of building UI in Rails from experience, not hypothesis. One example of this is really the lack of robust support for view caching in ViewComponent. We don't do a lot of view caching in GitHub, so it's been really difficult for us to build framework support for it. This is really one area where we could use your help. More broadly, this project has made me think about innovation in Rails. There is a book called The Innovator's Dilemma, and it's widely considered to be one of the most influential business books ever written. The Innovator's Dilemma is the decision between catering to current needs or adopting new innovations and technologies which will answer future needs. The book really demonstrates how successful, outstanding organizations can do everything right and still lose their market leadership or even fail as new, unexpected competitors rise and take over the market. And I think this is an important lesson we need to consider about the long-term relevance of Rails. The reason this matters so much to me is that GitHub's future is pretty dependent on Rails remaining relevant. We have so much built on top of Rails that it's very unlikely we'd rewrite our core application. So what does this mean for all of us? It means that we need to innovate. We need to experiment with new and potentially disruptive ideas like ViewComponent, because improving Rails is the only way we'll survive. We need to take ownership of keeping Rails relevant for the long term, by being good citizens, by participating. Rails was built by people just like all of you, and we benefit from the work others have put in. But we need more voices. We need more extractors. Many Rails developers have worked on multiple applications. We know what the underlying deficiencies are. We know what gems we add to every app we build. We know the pain points. And the survival of our companies depends on it, because picking a framework is forever. Rewrites are rare. But yet the world moves on, which means that it's up to us to keep Rails relevant. Thank you.